8.4. All right, so this is the last one, right? And once we're done this, it's going to be the probability unit. And for that one, we just have a project. So I'll be giving you guys that on Thursday. I think I had it for. So, all right, so 8.4. What we're doing now is when you get a shape like this. So if we've got a quadrilateral, so that's probably a new word for you. So quadrilateral, the word quad means four. So quadrilateral is just going to mean that we still got our circle, but we have this thing inscribed with four corners on this thing. So there's four angles in it. So it's going to be a quadrilateral. Okay. Then we just get some little patterns that are going to show up. So what we can say, first off, just for terminology here, angle A and angle C. All right, so how are those things related? So angle A is this one, right? That's that angle. And angle C, they are what's called supplementary to each other. This means like they're opposite to each other right now, right? And then angle B and then angle D are going to be supplementary to each other. So the way this works is that any supplementary angles always add up to 180 degrees. And that's really it. That's like a new thing. That's really going to be what this lesson is. So they just always add up to 180 degrees. And then the other part of that, well, which also makes sense, the sum of all four angles that are inscribed in a circle, right? It's not any four that's always going to work, right? But any four that are inscribed in the circle will have that 180 pattern, right? Okay, but it has to be inscribed in the circle for that to work. All right. So if we had a question like this, right? So it says, determine the values of X and Y in the quadrilateral below. So I see that they're all inscribed in a circle. And okay, we've got like point S, point R, point Q, and point P here. Would all be like my quadrilateral there. They want us to figure out this angle, and then they want us to figure out that angle. Okay, so there's just gonna be two parts in this now. So the first one, angle X, that's actually something that we've done in a previous unit or topic, sorry. Well, the way we can figure that one out, just to be a good little review here, is if I look at the legs, let's say of, from right there and right there, I can see that this angle, right, our central angle, is subtended by those 2 points, right? They have the same legs. They've got the same legs right there. So that they're subtended by that. And then so is this one. So this one is also subtended by those same 2 points. So this would be my central angle. That would be my inscribed angle. And our rule for that was that whatever your central angle was, the inscribed angle with the same 2 legs would be half of it. So angle X would have to be 140 divided by 2. Here, let's go 140 divided by 2. So that's going to be 70. So angle X has to be 70 degrees. Okay, so that's like step number 1. That's like a review from before. Now that I know that, now that I know that this is going to be 70 degrees, well, then it actually kind of helps me because remember what we just learned there. If I look at point R and point P, those two are supplementary to each other, right? They're on the opposite sides of each other in this case. So if that's 70 and this one plus this one needs to equal 180, well, then you can go angle R would be equal to 180 minus 70. So it must be equal to 110. That's it. That's the idea. So now this is a different style of question here. So it says a regular octagon is inscribed in a circle with a radius of 12 centimeters. The midpoint of each side of the octagon is 1.1 centimeters from the origin of the circle. It says, what's the perimeter of the octagon? So perimeter, remember, is all the way around the outside, right? You added up all the outside around the octagon. And they've kind of drawn for us a little bit. They've told us that the radius, they were nice enough to draw the radius in for us because we might screw that up, but they drew it for us. So that's that one, right? It's 12. And they told us that the midpoint so midpoint would be like right there, right? From there to there. That would also be our perpendicular bisector from previous topic. So we're pretty good to go here. We got the idea, but what we can figure out here now, I can kind of see I've made a little right angle triangle. So right there, right, I can figure out that green side of that triangle using Pythagorean theorem, right? So we can say just a squared plus b squared is equal to c squared, but we have the hypotenuse. So I'm going to call this, for a second, let's call that x for a second. So I'm going to say x squared is equal to 12 squared minus 11.1 squared. Okay, so then x squared is equal to, here, I'm going to plug it in here. 12 squared minus 11.1 squared. All right, so we get that as 20.79 is what x squared is equal to. So don't forget to square root that, right? Square root both sides. So we get x is equal to 4 point, and then there's a bunch of decimals, right? I'm gonna keep a bunch here for a second. 4.5596. All right, so really what you'd call that 4.6, right? But I want to use this number because I'm not done yet, right? That's for the perimeter. And I just found that one right there, right? So what I recommend is don't round that up to 4.6 or anything yet. Let's actually use as many decimals as we can. The best case scenario is actually to use the number that's actually in your calculator. I can grab that number and use it in my next calculation here, right? So I'm going to leave as many digits as I can. And then looking at this, right? Well, I'm dealing with an octagon, which has 8 sides, right? So probably a good way to do this, let's just figure out what one of these sides is. So one of these sides, if half of it, right, was that number, then I can figure out the whole thing just by going this, right, times 2. So I'm going to go that number. I'll go 4.5596 times 2 to get just the whole length there, just so it makes a bit more sense. So times 2. So we get, here, I'm going to call that length. That'll be the length there. So that's going to be, so the length would be 9.119, let's say. Just leaving a bunch of digits there, 1192 maybe. Okay, so that's what this length is up here, right? The top of that thing. And then just last thing to do, how many of them are there? Because it's an octagon. There's going to be 8, right? So now I just need to go that number. So I'll call that P for perimeter. So the perimeter is going to be that last number. So 9.1192 times 8. So that times 8. So we're going to get the perimeter of this guy is going to be 72.95 yada yada. But at this point, I could actually just round, right? I could, because I'm at my final answer. I would actually round this guy right up to just 73. And sorry, that should have been centimeters. Okay, and that's it. What I want you guys to do now, I actually made you guys another formative for these ones now. I just shared it with everybody this morning, and that's it. So for this one, for till the end of the week here I can stop the video here.